Hello, today I am going to create a program that solves the silly slots modules from the game Keep Talking and Nobody Explodes. This module is edgework dependent, so we don't need to check it. Let's see what the module looks like. There is a word at the top, a lever on the left, a keep button at the bottom, and 3 varying symbols with varying colors. Let's look at this one for our example. In this one, the word at the top is Steven, the first slot is a red coin, the second is a green coin, and the last one is red cherry. Let's look at the manual to see what we need to do. We see a grid that tells us what the slot's placeholder name is depending on what the keyword is. Since we have the keyword of Steven, we need to follow this row. Our red coin will become a silly sausage, the green coin will become a sassy sausage, and the red cherry will become a silly Sally. Now that we have our placeholder names, we can look at the list of statements we have at the top of the manual. If any of these statements are true, then we have to pull the lever and move on to the next stage. We do have a single silly sausage, so we must pull the lever. Our new keyword is sassy and our slots are blue grape, red cherry, and green coin. Our new placeholders are sassy Simon, silly Sally, and soggy Steven. If we look at the statements, we see having a single soggy slot is illegal, unless stage 1 had at least one sausage slot. If we went by our previous keyword, we can see that this statement should be legal. However, all slots placeholder has to go by the current stage's keyword. Therefore, the coin slots that were initially sausages turned into Stevens, and the cherry turned into a Sally, so we must pull the lever. Our keyword is now sassy and our placeholders are silly Simon, soggy Steven, and silly Simon. Since we have 2 silly slots and they're not both Steven, we have to pull the lever. Okay, last stage. Keyword is sausage and placeholders are silly sausage, soggy Steven, and sassy sausage. We have a silly sausage so the lever is being pulled. Luckily, since there can be a max of 4 stages, the module will be solved after the animation is done. Let's do one more example. The keyword is silly and the placeholders are sassy Steven, silly Steven, and sassy sausage. If we look at the statements, all of them are false, so we get to keep the slots. When we press the keep button, the module will immediately be solved. Now that we know the rules, it's programming time. Let's figure out how to do the user interface first. I decided to make the scene follow the order of how the user is going to see the module. So I had the keyword at the top, and then all the slots with their own color and symbol choice box. Since in a worst-case scenario, there would be 4 stages, and I may need to know the slots from previous stages, I decided to create 4 different windows so the user doesn't overwrite data I need for different stages. But in the end, they all look the same, with the exception of the stage number at the top. The first thing I did programming-wise was make a slot class that holds an object and color field, which are both custom classes I made that represents a slot's object and color respectively. I then made 2 methods that would convert an object into a noun placeholder and a color in an adjective placeholder. Then I decided to create a solve method for every stage considering they are a little different. In each stage I convert all the current and previous slots into their placeholders, and then I see if any of the statements are true. If they are, then I tell the user to pull the lever, if not, then I tell them to press keep. That's pretty much it. There aren't any tricks to this module, just follow the manual statements. Since this module takes a while to talk through, I'm not going to anymore. I'll just show you some examples of how the bot works. I hope you enjoyed watching the video.